Welcome to Get Smart with Stanford, where you learn better and achieve more. Today I'm going to help you master the laws of exponents. Are you in grade 10? Then this lesson is for you. Today we look into grade 10's laws of exponents. By the end of this lesson, you should be able to apply the laws of exponents for numerical and algebraic expressions. You should be able to simplify expressions involving exponents, and you should understand and use zero and negative exponents. An exponent is a way of showing how many times a number called base is multiplied by itself. We use exponents to write long multiplications more easier. We also use them to make calculations quicker. We use them to understand powers, growth, and patterns in mathematics and science. This is what an exponent looks like, where n on top there is an exponent, and a is the base. The base is always at the bottom. It is the number to which we need to show how many times it can be multiplied by making use of an exponent. Now let us substitute these variables by numbers. Let us say, for an example, n equals 3 and a equals 2. This basically means that our base will be 2 and our exponent will be 3. If we raise the base of 2 by an exponent 3, that means we are multiplying 2 3 times. 2 times 2 times 2, which is equal to 8. So whenever you see 2 to the power 3, you immediately know that it is equal to 8. We have 5 laws of exponents, namely product of powers, quotient of power, power of a power, zero exponent, and a negative exponent. Let us look into product of powers. Here we need to see what happens to the exponents when we are multiplying the same base. When multiplying the same base, we reduce such expression to one base and add the exponents. And this is what would happen if we had our exponents to be numerical values, whereby x squared times x cubed would give us x to the power 2 plus 3 and the sum of 5 as an exponent. And now let us look into number 2, which is a quotient of power. We get the quotient of powers when we are dividing the powers with the same base. Whenever you hear the word quotient, just remember that it comes as a result of dividing. If a is raised to the exponent n and divided by a to the exponent m, then we will have one base a to the power n minus m. The exponent of the denominator will be subtracted from the exponent of the numerator. Let us look into an example of x to the power 5 divided by x to the power 3. Here we would have to write one base, as the base of the denominator is the same as the base of the numerator. We would write one base x raised to the power 5 minus 3, which gives us the result of x squared. Going into number 3, power of a power. We get a power of a power when raising a power to another power or an exponent to another exponent. Let us look into an example where a to the power m is raised to the power n. This basically means that we write the base a and multiply the exponents. That will be m times n. Let us look at an example where x squared is raised to the power 3. That means it is cubed. That means we would have x to the power 2 times 3. and the answer to that would be x to the power 6. We are now multiplying x 6 times. That's what it basically means. 0 exponent. Any number that is raised to the exponent of 0 equals 1. But we need to take note that the base must never be equal to 0. Now let us make our base a numerical value of 7. If 7 is raised to the exponent 0, it is equal to 1. Any number that is raised to the exponent 0 equals 1. And the last law of exponents is the negative exponent. That is when a number is raised to a power of a negative. Whenever a number or a variable is raised to the negative exponent, we divide 1 by the same base which is now raised to the positive exponent. Let us look at an example of 2 to the negative 3 exponent. That is 1 divided by 2 now to the positive 3 exponent. As we all know that 2 to the power 3 equals 8, then we will have 1 over 8. And apply the same rule whenever we see a base that is raised to the negative exponent.